Hello, this screencast that you are watching today is about dividing fractions. We have been talking about simplifying fractions and multiplying fractions. And so in this lesson, we'll extend that notion to dividing fractions. I've got our first example up on the screen here, example 11. But if you'll actually take note of something here in the gray box, this principle is something that we've known for quite a while, that dividing by a fraction is the same thing as multiplying by the reciprocal. Okay, so P over Q divided by R over S is the same thing as P over Q times S over R. In other words, we flip that second fraction. And you've probably heard this in your either middle school or maybe ninth grade classes, where your teacher says, silly fraction, don't be shy, flip yourself and multiply, or keep, change, flip, or keep, flip, change, whatever you, KFC, you know. But the notion is that we're going to flip the second fraction because division is defined as multiplying by the reciprocal. Now, in this example 11 here, as I give myself a little bit more room, my recommendation is to, right out of the gate, go ahead and flip that second fraction. Before you start factoring and trying to simplify, go ahead and just rewrite that as a new problem, okay? So we've got P cubed plus Q cubed. Then down at the bottom, we've got 2P squared plus 2PQ plus 2Q squared. Notice I have not moved that first fraction. I left it alone. And then I'm going to change it to a multiplication sign. I'm going to flip the second fraction. Now it's going to be 6 on top. P squared minus Q squared on the bottom. Okay? Now, I can go ahead and start factoring everything. You may recall that first fraction on the numerator, this year I have not gone through the sum of cubes with you guys before, but I did tell you there's a formula to be memorized. So the way that first numerator, I'll go ahead and let that cat out of the bag, so to speak here. The way that it factors is P plus Q, and then P squared minus PQ plus Q squared. Okay, that's called the sum of cubes, and that's just a particular factorization technique that we have memorized. And you'll notice now we're multiplying. So really all I'm going to do is just multiply the top with the top, and then the bottom with the bottom. I'm going to factor that 2 out right down there, and be left with P squared plus PQ plus Q squared, okay? And then down here in the bottom, I'll have the difference of 2 squares, which you guys should be familiar with. So P squared plus PQ plus Q squared, and then P plus Q and P minus Q. Okay? And then we start canceling out. So we want to cancel common factors. You'll notice that trinomial, actually, you know what? Shame on me. That trinomial does not show up in the same. Hey, why can't I cancel that? Can you guys spot it? What mistake did I almost make? Why can't I cancel those two trinomials? If you've spotted it, the signs are not exactly the same, right? So remember, to cancel out an entire, in this case, trinomial, it would have to match exactly. I'd have to cancel the entire thing. And since that's not the exact same trinomial, I can't cancel that out. So I was almost hastily making a little error right there. I'll cancel out my P plus Q, and then I'll cancel out a 2 with this 6, and that's going to leave me with a 3 because, of course, 6 is the same thing as 2 times 3. So the way to answer this question here is we would say, all right, my simplified result will be 3 quantity P squared minus PQ plus Q squared. And then down at the bottom, P minus Q and P squared plus PQ plus Q squared. Lots of P's and Q's on this one. I hope that makes sense. Again, it's nothing new other than the flipping of that second fraction because we saw a multiplication sign. All right. So another type of problem that we'll encounter is what I like to call a complex fraction. Or I'll say, oftentimes in class, I'll say, ooh, we got some fraction on fraction action here. And really, this is just one big divide by sign. If you recall that a fraction bar, look at what I'm highlighting right here, that really is just one big division problem. Okay, so this is exactly like, watch what happens here. Thankfully on OneNote, this will be pretty straightforward. This is as though, instead of having that fraction bar, this is as though I'm saying, hey, the first fraction divided by the second fraction. And then it becomes a problem just like the previous one. You notice this note right there that says something to that effect. So let's go ahead and flip the second one and factor at the same time, okay? So we're going to flip the second one and factor at the same time. 6 times 2 is 12. looks like it'd be x minus 4 and x minus 3, and then we put the 6 back, and we're going to kill off some common factors of 2. So 3, 2, kill off common factor of 3, so 2 and 1. So that first fraction's numerator would factor out, I'll do it in red up here, it would be 3x minus 2 and 2x minus 1. Again, if you want to, you can go back and check to see how I factored that out, or better yet, even just FOIL it out and you should get what you started with. Down at the bottom, we're going to have a factor out of 4, and we'll have an x minus 2. And then remember, we want to flip this fraction. So when I factor it in my head, I'm going to put the two factors that are on the bottom here, right? I'm going to put these two factors actually up top. Now ask yourself the question, what are those two factors? It should be x minus 6, oh excuse me, x minus 2 and x minus 3, because we want that positive 6. It's going to have to be a negative and a negative. And because we want it to be negative 5, we're going to add it up, negative 2 and negative 3. So that's how we factor the bottom. And then again, we've got another magic method here up top that we can factor out. I'll do this in blue again. 2 times 3 is 6. So we got x minus 6 and x minus 1. Bring the 2 back. Kill it off if there's a commonality, and there we go. So again, that's going to go on the bottom because we're flipping it to change the multiplication. It'll be 2x minus 1 and x minus 3. Okay, now I do like to do a little color coding, so if you'll bear with me here, I'm going to clean this up and I'm going to show you exactly where each of these factors in red came from. Okay, so these two factors right here came from our original numerator of the first fraction, right? It stayed up top. That's pretty easy. The 4x minus 8 and the 4 quantity x minus 2 again. So you can see I did not change those factors, their position in the fraction, but watch this. Over here, the numerator of that second fraction, its two factors actually went down to the bottom. Okay, and then lastly, let's see if I can do this. These two factors, I know that might be a little hard to see. Those two factors came up top. Okay, now with that being said, I want to see if there's anything that I could cancel. Okay, anything at all that I could cancel. And actually, if I were in class, I would say, okay, well, you tell me what cancels. Okay, have you spotted a few things that cancel? We got an x minus 3, we've got an x minus 2, and we've got a 2x minus 1. So this one just boils down really, there's not a lot left other than the, whoops, I already took care of that, didn't I? The fraction bar was a little too long. 3x minus 2 on the top and 4 on the bottom. Okay, so even if you've got what we originally had, which was, you know, a big fraction on top of another big fraction, right? This is what we originally had. You can flip the second one, change it to multiplication, and it will be workable just like the other ones. Here's an example for you to try on your own. This is again a division problem, so please flip that second fraction and multiply. Go ahead and stop the video now that you're watching, and let's see if when you're finished you can check your work and see what you got. Alright, so hopefully you've had time to work this out. Let's get down to it. First of all, factoring z plus 1 and z minus 1. That's the difference of two squares, right? Down here, the denominator of this second fraction is z plus 1 and z squared plus z, oh pardon me, minus z. Fix that real quick. Minus z plus 1. Again, that's the sum of cubes. We talked about that a moment ago. Here we would factor out a z. We'd be left with z squared minus z plus 1, which is a perfect square trinomial. No, not a perfect square trinomial. We just leave it as it is. And we want to flip that fraction, okay? We want to flip that fraction. So what's left up top would be 2z squared, z plus 1 from the denominator of that second fraction, and then that trinomial. And then what's on the bottom, z plus 1, z minus 1, and then we'll put the z up front from the numerator of that second fraction, and z squared minus z plus 1, which now we're free to start canceling some things out. Those absolutely do match up. Here we'll cancel out the z, and we'll be left with 2z up top and a z minus 1 down in the bottom. So that's 3 real quick examples that we just ran through, right, of dividing. And again, division is the same thing as multiplying by the reciprocal. So this is no real difference to the examples that you and I have worked earlier in the week with multiplication. It's just in these cases, we got to be on our toes, and we got to make sure that we flip that second fraction. Now, I say putting it all together. Look at this last example right here with me, example 14, and then the lesson will be yours. In this case, you notice there are 3 fractions. And some of the classwork and homework questions that you guys encounter will have 3 fractions. So here's how I would handle it. The fraction that's being multiplied, leave it alone. The fraction that's being divided here is the one that we want to flip. So just flip the only one that's being divided. And then just factor everything. Just have a big old factoring party here. So we're going to take out a 3 and then be left with x minus 2. We're going to take out a 4 and be left with x minus 1. We've got x plus 3 and x minus 1. Do you see the rapidity with which I'm factoring these basic trinomials? That's the goal for us here, okay? I'm talking and I'm working, but at this point, fellas, we've done enough of these to where we should be able to factor out with pretty rapid success. Taking out a 2, and you'll notice again I flipped that second fraction, so the 8x plus 16 is now up top, and then we're going to cancel some things out. Let's see now. We've got, oh, there's an x plus 2, and there's an x minus 1. I'll take out a 2 from that 8, leaving me with a 4, and then I'll take out a 4 down there, and it looks like I don't think I've got anything else that cancels out. So let's write up our answer. We got 3, x minus 2, x plus 3. And we've got x minus 5, x plus 6. Again, please, 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 please fight the temptation here to say, oh, look, I've got an x on the top and an x on the bottom. I'll just cancel that out. Or, oh, you know, look, there's a 3 on the top and there's a 6 on the bottom. I bet some stuff can cancel out. Remember, those are terms, and we cannot cancel out terms. We can only cancel common factors. There's no common binomial factor there. Look, I hope you found this video helpful. It is just the same multiplying and dividing as far as your technique goes, with the one small caveat of, you know, flipping any fraction that gets divided. So if you have any questions, let me know. Other than that, work hard on your Delta Math assignment, and I will see you guys in class on Friday. Thank you.